Hi, this is Daniel with TrustGraph, and I'm here to go into a little bit more detail about a post I recently made on Dev. We also posted it to the TrustGraph blog. We posted it a couple other places, and the results, the feedback wasn't exactly what I was expecting. And I thought, well, maybe I should talk about what I expected and why maybe I didn't get that kind of response initially. So let's actually look at the post. So I posted, I think it was, I think it was on Monday. What does LLM temperature actually mean? And the reason I posted this is because for the most part in TrustGraph, in our what we're calling a naive extraction, where you ingest documents and you build a knowledge graph and map vector embeddings, where you don't really know anything about the documents you're ingesting. We were operating under the assumption that you would want the temperature to be set as low as possible to prevent extracting information that wasn't in the original text. Um, Recently, I've been doing some tests for what we're calling document level metadata. And I've been under the assumption, like, what if we collect a lot of data on a one pass on an entire document and then use that information to seed during the chunking process? And I accidentally set the temperature to one in a case, and the results look like really good. And when I set the temperature to zero, the results were worse. So I found that very odd. And that's kind of what led me down this road of starting to do some testing where I do nothing but vary the temperature. So I guess we should talk about first, what does temperature mean? And I took this is the actual definition from Google AI Studio. And they use the word, deterministic, which is kind of how I view it too, is that the lower the temperature, the more deterministic the LLM output should be. Now, we know that large language models are not fully deterministic, but we tend to think, or at least I had thought, of temperature as being a rough measure of that. What does determinism mean? I came from a world of, safety critical systems, really high reliability systems. So, I'm really familiar with the term, but I find that some people are not as familiar with it. Determinism essentially means that a process is fully repeatable, 100% of the time. Now, of course, 100% is never really achievable. So what are we talking about? We're talking about 99.99% of the time, or more realistically, 98, 99, or actually it can be that high depending on the system. When you look at, safety critical aerospace and the space world, these systems are, you're measuring safety factors and 10 to the minus 5, 10 to the minus 6, 10 to the minus 8 in terms of occurrence of some of these events. So, that's kind of what I mean when most people use the word deterministic. So what did I do? I used Gemini 1.5 Flash, the latest version. We found it to be very good for knowledge extraction. And I varied the temperature in these increments from 0.5, 1, 1.5, and 2. No, I don't know why. Google decided to, make their temperature settings go from 0 to 2. I think there's some models it can go as high as 5, and I don't really, I don't know what that means. And honestly, after this, my test results and what I'm about to show you today, um, I still have questions over what it means. So for all the tests and all the tests I'm going to do for you today, top P is 1, top K is 40, and I'm setting the max output at the maximum, 8192. And so what did I see? The things that, I saw that was odd are these are three different runs I did at these different temperature settings, and this was the extracted output tokens. And what you see here is a huge amount of variance. And this is for a document we use a lot at TrustGraph. It's the Rogers Commission report from the NASA Challenger disaster. And I'm going to go into a little bit more detail about why we do that. And what I'm essentially doing is asking it to perform a knowledge extraction for entities and topics and a little bit of the types and a little bit of context for each of those for the entire document. Then I did the same thing on a much smaller document, which is actually a briefer discussion about the decision making for the Columbia Space Shuttle disaster. And you see these results are uh, a lot more consistent. But so what am I really talking about with knowledge extraction? I'm talking about providing a text and finding entities. And what do I mean by entities? We typically think of entities as, you know, people, places, things, organizations. Uh, we typically separate topics, conceptual topics, from entities because we find most language models struggle to differentiate the two. If you tell it to only find entities, it might not find topics. So we separate them, although some models, they will return the exact same list of entities and topics. We find that some of the models that we consider the best are like Gemini 1.5 Flash, Claude 3 Haiku. Uh, they tend to do a pretty good job of separating the two. And yes, as of today, if anybody were to ask me what are the two best models for what we do at TrustGraph, it would be Gemini 1.5 Flash and Claude 3 Haiku. And this is relevant, though, for more than just knowledge extraction. Uh, a point I like to make is that I wrote an article a while back that also I think a lot of people kind of didn't really see the point I was trying to make, and maybe I'll revisit that in another future discussion, is the act of asking a language model to perform a summary. A knowledge extraction is essentially kind of part one of a summary. You're asking the model to read the text and find important information. And then you're asking it to make value judgments on what's most important. Well, with a knowledge extraction, we're kind of just doing the first half of that. Read the text and write what you find. And we're not asking to write anything else, not to generate any sort of opinion or prioritization of that information. So these are the base results I got with my runs. And let's actually look and see how I did this. So this is a notebook, which I actually have uploaded to a repo, which is linked down below. You can see where we're importing the Google AI Studio packages. And I just have both of these PDFs stored in the local directory, just doing a really basic extraction. And you can see like they are extracting, and they're very long documents. The Rogers Commission report is about 250 pages, very text heavy. And right before I started this video, I did a run with the temperature set to 0. You can also see I've set the response schema in the way that the Google AI Studio likes it to be set. In this format, you can see we're getting some base information about the type of document, who the authors of the document are, but then finding these list of entities, a type of entities, information about the entities, and the same for topics as well. The idea being that once we got that at a high level, we could use that information to improve how we did the extraction on the individual chunks. Also, so this is the safety settings for Gemini. And you can see I have the civic integrity one commented out. I'll show you why I have it commented out. Because if I do this, I get this. I have this tab open because this is the actual documentation from Google, which says it's in there, but it won't work for me. The others do. We've actually run into issues like this before where the safety settings don't work the way they're documented. So if anybody can get civic integrity to work through the API, please let me know. I'd love to know what I'm doing wrong. Otherwise, I'm just going to go back to commenting that particular one out. We used to set all the safety to block none, and we found that stopped working a while back. I don't know if it works now. So you can see here, I am setting a system instruction where I'm giving the model a little bit of insight into what I want it to do. I'm calling it information retrieval. I'm not sure, I'm not using the term extraction. Sometimes in the past, I've called it an NLP-like task. I haven't seen a huge amount of difference depending on that wording, but I can't guarantee it. I am telling it to, extract into a JSON schema, giving a little bit of idea about what the entities could be, a little bit of idea about what I mean when I ask for context, and then I'm telling it the topics are intangible concepts. So this is where you set the prompt, and I like to do this to get a little bit of idea how long it's going to take. And you can see already this particular response didn't return what I expected. We got 738 output tokens. And if we go back to the report, you can say I mostly, when I would run at this temperature setting, would get a maximum output, except for this one time I got 1511. So this time I've actually gotten less than all of those. So only got 738. So, and this is kind of part of the point I've been making is that the level of inconsistency. Let's run it again. I would tell you I knew what it was going to be, but I honestly I don't at this point because it's not doing what I would expect. Um, Depending on how long this takes, that kind of gives us an idea of how much is going to be in the output as well. So if it finishes relatively quickly, like that, 12 seconds, which was very similar to the last one. So I'm going to assume it's going to be a similar size response. Yeah, it was. Very, very interesting. So that's an interesting. What I'm actually doing here is just seeing the kinds of people, and I'm going to get to that a little bit later about people. I want to make another point first. So let's start increasing the temperature and see what happens. Um, Part of the reason I did this is because my initial hypothesis was as you increase the temperature, you would likely get larger responses. And, kind of what I found when we look at this table is that was true to a point, and then it kind of dropped back off. As you see, the smaller document was just much more consistent in general than the larger document. So let's see, this did finish 15 seconds. So that probably got more this time. And we did. We got, 1019. So we increased the temperature, we got more, still kind of inconsistent with what we were seeing before, where I was getting these maximum output responses. And just to make sure yes, I am using the larger document. It comes out to be like 176,000 tokens, which were for Gemini 1.5 Flash. This is approximately 17.6%. The advertised context window, which if long context windows are really effective, you would think that that would be nowhere near pushing the boundaries of reliable outputs. But as we're seeing, that doesn't really seem to be the case. So let's increase it up to one, and again see what happens. And the past results, this is where I kind of this seemed to be an inflection point where you would see this increase from 0.5, you would see in how much we extracted. And then when we got to one, it seemed to level off and maybe go back down again. But at this time, this response is already taking longer time. Yeah, so we probably got more this time, and we did. So it's going up, which would have been my initial hypothesis. This is interesting though. We're getting, so when do I want to start talking about this? One of the reasons I even started going down this road is because I started to notice that the types of entities found changes as the temperature goes up, specifically people. So this is really interesting. And um, actually, that actually didn't work the way I thought it would. Hold on. Did I not extract the JSON? That would help. Yeah. So you'll see, wow, we actually got, that's the most people I've ever got through this extraction. That's interesting. And this one is really interesting too because of some of these names. Actually, there's a name in particular that caught my attention. Okay. Since I see this name, this is the first time actually running these tests, I've seen this name. And there's a reason why I want to bring that up. Because one of the reasons why we use this report a lot with TrustGraph is because we know it really well. And two, it's long. Three, it's very complex. It has lots of unique terminology. And we find that there aren't a lot of public sources that really reference these events and this information in detail. So most LLMs don't natively have this in its vector store. So if and also this report is interesting because most of the names, like for instance, the last run I did mostly returned the names of the crew of the Challenger. They're actually only at the beginning of the document, believe it or not. So this this kind of page is kind of the only one, and maybe like one or two other times where the crew are actually mentioned by name in the entire document. The reason why the name Keel got my attention is because kind of buried in the middle of this document is where we start to see the actual transcript. This is what we're seeing right here. These are the transcript from the commission. So these are, people being interviewed. And what do we see? We see lots of names. We see, and you see this name, Keel. But what's interesting, so we do see Keel here, but you might have noticed there's a lot of other names like Loving Good. I think what's another one? Reinhardt, but we don't see those here, which is interesting. And without going into picking this apart, as you can see, there are quite a lot of names in this section of the document because again, it's actual from the commission where people were giving their testimony. But if you really want to understand the important information in this document, this is actually kind of where it is. This is the actual testimony that these people provided on their perspective on the incident. Here's another name, Bob Lund. I don't believe that one's in the list, is it? I don't see it. No. So again, if you really wanted to understand, if you had questions about, hey, I'm trying to understand what really went wrong with the Challenger in a very fine-grained detail level, you can already start to see, we're seeing some of these, but not others. For instance, we got the name Keel, but we didn't get the name Lund, we didn't get the name Reinhardt, we didn't get the name Lovingood. So let's see what happens. Again, let's just keep increasing the temperature and see what happens. Oh, that's interesting. I'm left a zero in there. I don't know if that would have affected it or not, honestly. Let's see. As responses get longer, I have time for a tea break. And Gemini 1.5 is still, oh wow. I was about to say it's still the fastest, but I was expecting it to take longer. So we can already tell this is probably going to be a smaller output. It is. We're back down to 988. Let's see what kind of names. Um, so this is interesting. as the temperature has gone up, we've actually now found one less name. And here we're only getting, I believe, those are last names. We didn't even get the first names. Oddly, we're still getting that Keel name. I don't really know. I couldn't tell you uh, why that is. Let's take the temperature all the way up to 2 and see what that happens. And again, this is not, as you can see already, this isn't entirely consistent with what I've seen in the past. We haven't seen this. Okay, that's very quick. Um, so at 2, we do have a couple of cases where we saw these very small responses. I'm assuming that's what we're going to see here is a very small response. Very small response. Okay, wow, we didn't really find much of anything at all that time. Um, that one's so interesting. I think I want to run it again. That's the smallest I've actually seen. Which again, my initial assumption was turning the temperature up would have generated the biggest responses, not the smallest, which was obviously incorrect. So again, um, that's a huge swing, though. We just went from almost nothing to 444. That still pales in comparison to the others, but still, that's a huge. Wow, we're still getting that name Keel. That's really interesting. So who have we gotten in this one? So this time, oh, this is fascinating. We've gotten this name that's buried in the middle of the document. Reagan, who's at the beginning, and Neil Armstrong, who didn't even have anything to do with the Challenger at all, which means we're missing a lot of names, and it's a very odd selection of persons that it would find because even though it found the name Reagan, which is probably from, if we look at the very beginning of the document, I think it has Reagan's name. Yeah, so we have Reagan's name right here. You would think that if it decided to extract Ronald Reagan's name as being important, it would have continued to extract these names as well, but it didn't in this case. I'm a little curious as to why we're not seeing it hit its token limit. So let's set the temperature all the way back down to 0 and see if we can get it to. Because again, so I saw this. This was the most common output I got is 8192, which means the output actually was exceeding the max tokens of the response, which meant you're getting actually invalid JSON, which means if you're trying to do a bulk process where you're processing thousands of documents, this would have just been an error because it would have returned an incomplete JSON object. And wow, that one didn't take very long. So we're not getting any of those big ones, which again, I don't really know how to explain that. In my past testing, that was my most common output. So here, what are we getting? We're just getting the names of the crew. That's all we're getting is actually that last one. I'm not sure. Is that name? Yeah. So here we are. We're getting that list at the very, very front of the document. That's all we're getting. And as I said, if you search for these names, this is basically only where the crew names are, believe it or not, in this document, because it's mostly about the testimony of other people. So all those people at, in this middle section where we're getting testimony, we're not getting, any of those people. Now, just for comparison's sake, as you can already see, this is hugely inconsistent. So let's go to the other document, which is a much smaller document. It's on kind of similar vein, but it's on the Columbia disaster, and it's only around, I think it's around 20,000 tokens, so considerably smaller. And what I'm expecting is it to be behave more like this. We're going to see it be much more consistent. This is already a little bit surprising that it's taking this long, because even though we know this is a much smaller document, and again, just to be clear, we are using this as the API that does have the option to put in a chat history, but we're leaving that blank on every single API call, which Now, in theory, we would think that means there would be no, memory associated with these calls, but the behavior is odd. And okay, so here we have a very odd behavior. So this is the first time I've seen this. Oh, welcome to the reason why I wrote this article in the first place. I hope you're beginning to see why I did this. Um, all the times I've tested this before with this document, and again, this is text to just to make sure I didn't do anything stupid. Text to is this one. It's the smaller one. Matter of fact, this is going to output a lot, but let's just do it to make sure I haven't done something really stupid. This is the Columbia report, which is much smaller than the Challenger report, which also doesn't have people, so I can't really prove that point in this one. But um, yeah, accident in Columbia. Uh, so from a percentage perspective, this is very interesting because we've extracted the maximum, which also means in TrustGraph, this would throw an error because this is an invalid JSON object. It's incomplete, as you can see, right here. For 24,000 input tokens, we got the maximum output. And in the previous times I tested on this document, the highest I ever got was this outlier at 747. The second I got was 696. Um, so now and this is very interesting because I mean now I'm tempted to just um, I don't need to delete that and just do it this way again. I mean, now I'm beginning to wonder, is that why would that matter? It shouldn't, but hey, I'm testing everything here. Um, because every time I tested this before at zero point 0.0 for this document, it was, as you can see, it returned the same amount all three times. Now it's not doing that. And again, we're seeing it take a very, very long time, which leads me to believe we're going to get a very long output again. Yeah, that kind of seems what's going to happen. I think that's pretty similar to the time that it took the last time. So what have we gotten? Same thing, maximum output. Hmm. So again, I never saw this behavior with this data set before. Let's change it to zero point 0.5 and see if that starts to follow the pattern. I mean, as you can imagine, oh wow, is it already finished? It's okay, so was not expecting that. So this is much more in line with what we were seeing before. Uh, that's that's much closer to what I was expecting. So 517. And now I'm inclined to do this. I want us to go take it back to 0 and see, do we get these maximum output ones again? And I realize this is a little bit, what's the word I'm looking for? Well, it is mundane. It's not particularly exciting, but I don't find people have really done these kind of experiments. And this is how you test to see if a system is really predictable, if it's really reliable. And I've been testing this quite a bit over the past few days, and it's not even behaving how I expected. Like, this is the first time it looks like we're going to get yeah, 30 seconds. That's probably going to be another maximum response. Um, this is the first time I've had this happen with this data set. I have not gotten it. And as you can see, it's very much very unique topics to this particular document. But every time I tested it before on this document, it was very consistent at again 340. So that was actually one of the conclusions I put in my blog post is that it seemed like uh, the smaller context window made the model behave a little bit more predictably. And at that point, at this point, I can't even say that anymore. Um, so now I'm going to change this back to the Rogers Commission report, which of course is just to make sure I'm doing the right one. How much input tokens? It should be around 20 something, yeah, 24,000. Okay. So now we're going to set it back to the Rogers Commission report, which again is 176,000. See what happens. This is the one I would expect it to return the maximum amount of tokens, and which it normally does. But so far in the time that I've been showing you, that's not happened. So let's see if it happens this time. And it doesn't appear that it did. What did we get? 730. And we've once again gotten this list of people that are only the ones at the very beginning. So I'm going to take this up to 1.5. 1.5 oftentimes I have found seems almost to be this magic number when it comes to finding people. So let's see what happens. Because I want to see if I can find some of those people in the middle. Seems like we're getting more extraction with this task, this run. I probably should have told all the viewers out there to make some coffee or tea while we're doing this too, while we're waiting. What do we have here? Again, I actually don't see, I do see, well, I see that name, Keel, which is interesting that it's picking that name and not some of the others. So we do have well, we have that name, we have this name, which of course is in the middle. You know, I don't, of course, it's a 250-page dense document, so I don't know it in its entirety. But um, matter of fact, let me do this. I'm curious now. I wonder where that name appears in the report that way. And it appears that it doesn't. Okay. Oh, here it is. Oh, okay. Interesting. Well, now we see. What are the names we see? Rummel, Sutter, Walker, Whelan, Yeager, Keel. Right, Rummel. So that's where the names are coming from. And what is this at? It's at the end. So we're seeing, actually, it looks like, because we didn't actually get the names of the crew this time. And the name that sticks out from that list, of course, is Christy McAuliffe, who was, of course, the school teacher that was on Challenger. She was not an astronaut, which is another reason why the Challenger disaster made so much news. And as you can see, her name is not in this list. So this time, even though we got more people, we got them from a very specific location in the document, the end, which that's kind of one of the points I wanted to make. Actually, I'm not even sure all the points I want to make. Um, to me, this testing just confirms something that was talked about last year. If you read the paper Lost in the Middle, which I highly, highly, highly recommend, they ran tests, and I forget who actually wrote that paper. I'm sorry to the authors, but it's a great paper. They found there was a bias towards the beginning of a document and the end of a document, and that anything in the middle tended to be just ignored by the language model. And that's exactly what we're seeing here with these tests when we're looking for people. Um, we're seeing it either picks out these people in this list at the very end, 207 of 261, or we're getting the list of people at the very, very beginning of the document, along with, President Reagan's name. But if we go to the middle, where to be honest, the real meat of this document, the real meat of information, of knowledge that you would want to know when all of a sudden we see names like this, McDonald, Lund, uh, so many of the other ones that we've talked about before, Reinhardt's, Lovingood. Um, we haven't seen Gemini find those names a single time. And what this does to me is, I think there are 2 points, that two conclusions I would draw from this. Um, for information extraction, the temperature setting doesn't really seem to produce results in a way that I would expect. I would expect that, and I guess I should caveat with that I expected that if you allow for lower probability tokens to be selected, I would think that you would probably get more output. But it seems like because you're trying to fix the model into a response schema, we've given it this JSON structure and said, you have to respond in this schema. There seems to be a limit where you increase the temperature and all of a sudden the probability isn't high enough to actually populate those values. So instead of getting more output, it starts to go down again. But where is that sweet spot? I guess also I should mention that one of my reasons for always selecting a temperature of 0 is because I thought, well, I don't want it to hallucinate. I don't want to extract some information that's not actually in the text. Uh, I've actually not seen that, at least with the testing of a model like Gemini. Even when we set the temperature to 2, there doesn't appear to be any information in the extraction that wasn't actually in the original text corpus. So for an information extraction task, it doesn't seem like temperature has any bearing on hallucination. Um, in fact, it- I'm not even confident in saying how temperature equates to that. It seems like setting it 0, you're more likely to limit what types of entities it finds. Um, and again, I this is really hard to demonstrate right now, but my personal experience has been that persons are the ones that are really affected by this. And I don't have an explanation for why that is. I don't have an explanation for why you increase the temperature, you start to see more people in the extraction. And again, even during these runs that I've just done, we didn't see results that correlated with this. We couldn't even reproduce the max output runs for the larger Rogers Commission report. On the other side, we did get that for the smaller document, which I never got before. But when we turned up the temperature, it began to respond kind of more as we would behave. I think the thing I can say, though, with quite a bit more confidence, is that loss in the middle is still a problem. We never saw a case where we found those names in the middle. And for a RAG process, that's really important. The whole idea is that we want to understand this report with a very, very high level of detail. And if we're not pulling all those names from the middle of the document where the actual expert testimony was, we're really, really, really missing out on the most important information in the document. And I think that that's not necessarily, I don't necessarily think that this is all that bizarre, because think about how we're training most of these LLMs, most of the data sets we're training them on. We've all been taught to write where what comes at the beginning of a report or a document. You have an introduction, you have a summary, then you have the body, which is everything in the middle, and then you have a conclusion. Well, you jam pack that introduction or that summary and that conclusion with really meaningful information. Whereas the body of the document, it's much more spread out. So if you think about it from a knowledge density perspective, the beginnings and ends of the document have the highest knowledge densities. And the density in the middle is much more inconsistent. So I have a bit of a hypothesis that most LLMs have developed a bit of a bias towards the beginning and ends of a text corpus, just because that's how most everybody's been taught to write. That there's a summary and then there's a conclusion and then there's stuff randomly in the middle. Well, what happens when we're really interested in that random stuff in the middle? Well, it seems like the long context window just it's not going to find it. And I know that people like Google and Anthropic and OpenAI, they continue to publish lots of reports claiming success with these longer context windows, and it didn't work just now. I mean, that's all I can say. It didn't work just now. Um, and the only solution I see to that is to continue chunking the text. That's what we do in TrustGraph. When you do a bulk ingest, it's going to chunk the documents to however you set it. We found, not surprisingly, chunking smaller tends to yield better results. And I was really hoping we could add a process to the beginning of that would allow us to get some of this higher level keywords and entities and topics from the entire document to be able to see the further process, but it appears that it's just too inconsistent. Because right now I'm imagining, because we're actually doing this for one of our TrustGraph users right now, we're doing a bulk ingest where we're talking 3 to 5,000 documents. And we can't go through and examine each one of these documents. That's the whole point, is to automate this. And as you've seen, just on the test I've run today, huge amounts of variance in the output, which means what happens if it's one of the times that it's a max output, which is invalid, or it's one of these outputs where it's almost nothing. Um, in the span of a huge bulk ingest, that all of a sudden means this document would be effectively lost. And sure, in a data ingestion pipeline, there is going to be some acceptable amount of loss in the pipeline. But what is that number? Is it, what is it, 5%, 10%, 20, 30? I mean, right now, this process I don't think is reliable, even 2/3 of the time. I think it's less than that. So what's the point in trying to automate a process if you're only going to get about 50% reliability, or 2/3 at most? So I don't see any evidence. I'm not going to make any broader than that. In all the testing that we've done, in the testing that I've done personally, I just haven't seen any long context LLMs or long context windows be able to really work on those fine-grained details that are buried in the middle of these very complex documents. And the only way I know to solve that problem is to continue to chunk the documents. And I'm not even sold on some of the more sophisticated semantic chunking um, techniques at this point. I think some of the semantic chunking techniques are very sophisticated, very clever, but do they actually give you improved results, especially considering the cost? I mean, literally, there's a cost because you're going to consume a lot of tokens inputting the entire document in the LLM, and also the latency. And if you're doing this for huge amounts of documents in a bulk ingest, all of a sudden, how much time do you add in the latency? And if you're doing this in a cloud deploy, which means you need compute and storage resources, adding that additional latency to the process adds considerable cost. So I'm not convinced yet that these more sophisticated chunking methods, aside from a purely a simple recursive or token chunker, provide additional value. So that's all. That's what I was really getting at with this article. I think I learned my lesson that from now on, if I have a more complex message that I'm trying to convey, I won't try to convey it in 500 words. I will make a video and talk about it. Now, we do have some more blog posts coming up soon that are going to go into some of the details about how TrustGraph works and how some of the CLI and new features are working. But I really wanted to share this. I also wanted to share this just as a partial sanity check for myself. These results don't make sense to me. It's very unexpected. Um, every time I run these tests, something different happens. As I said, the notebook is below. Um, let me know if you can't recreate my results. Let me know if we're doing something wrong, because otherwise, um, I don't understand why people aren't talking about this more unless we're just doing something that nobody else is. And I don't know if that's a good thing or a bad thing if we are. So thanks for taking the time to listen to this. And I hope that either if you know what's going on, please, by all means, tell me. I would love to know, and look forward to sharing more with you.